during the keynote, I'm going to go a little bit more in detail around our experience doing the software selection that led to the choice of String Native Pulsar. But also, part of the requirements, if you recall, I mentioned decouple architectures. One of our requirements is we want a platform that is decoupled, which means that we're not tied to particular technology stacks. So I had to look into how to accomplish that feat. And so the other part of this lecture is using Dapr. So I'll go into Dapr, what is Dapr, and how we went in that journey. So it's all part of a journey, right? So I mentioned this, we talked about that. So I get into a bit of who is FICO, and I won't repeat the joke. I mean, FICO, everybody's, at least in the US, says, okay, FICO, oh, yeah, credit scores, credit scores. But FICO is much more than credit scores. We have a whole ecosystem of solutions, services, capabilities that are deployed in a platform. So if this is the evolution that I had in the lecture and the keynote, I sort of have more detail on this one. But in an essence, 68 years ago, Mr. Fair and Mr. Isaac got together and came out with an algorithm to predict the likelihood that someone would pay or not pay their loan. That's analytics right there. So back then it was revolutionary, and it gave origin to the whole credit industry. And so out of that, obviously, we grew through building things and through acquisitions, and started a separate, back then it wasn't a separate line of business, it was part of FICO, but it evolved into its own profit and loss line of business at FICO. It's a software group. So we have a whole ecosystem of tools, products, that have grown to address specific needs in the market for specific problems. And I'm sure, like in your companies has happened as well, that these particular silos, these verticals, become very profitable, become very entrenched. Customers love these products. And so you find yourself as an enterprise architect that you can't move forward into how do we generate additional value. Because the point of the way you achieve additional value is by breaking these things, taking out the commonalities, and creating smaller building blocks that the customers, yourselves, FICO, partners, and the customers themselves can combine in different permutations, generate value. So we've gone through this path, and we moved to the cloud, and we started decomposing our point solutions. And we are now on a platform-first basis. We are in the middle of our North Star adoption program, where we're looking at the future, how we're going to continue evolving while we're delivering value with the platform that we have today in place. So it's like the old metaphor of changing the spark plugs of your single engine plane while you're flying it, right? So having said that, what we have is truly a platform that helps customers make better decisions, faster decisions, and more profitable decisions. The challenge when you break things, and probably you've experienced this, is when you break business processes and capabilities into small building blocks, you generate additional work intercommunicating these components in different communication paradigms. And so we needed a more robust way to build one of our architectural services with better technology. So I'll get into that. So let me, very quickly, I mentioned this in the keynote. FICO is about generating business value from data. So it's a virtuous cycle. You have data, or customers provide data that we massage. We applied, it's what's called applied intelligence. So we use 3 pillars of technology: decisioning technology, optimization technology, linear, nonlinear programming, that sort of mathematical models, and analytics of all sorts. And those 3 pillars combined in different creative ways allow our customers to look at their data and decide, make better decisions. But then those outcomes are sent back to the system, the original systems the customer has, and they're operationalized. So these are decisions that are taking place in their business processes. And they can monitor the outcomes and see where they need to tweak it again and then repeat the process again. So that's the whole idea of this virtuous cycle. That's what we do all day. So when I talk about the North Star platform, what are we talking about? So we're talking about this decomposition. On the left, you have some of the key products that we sell in the market for our customers, and they can combine these products in different ways. So the platform allows, at a coarse grain, to combine these products to create new value. Maybe it's in any aspect of customer life cycle. So before you acquire the customer, all the way through, or you acquire the customer. So one of the key things, the common theme that we offer is hyper-personalized customer experiences. So we can offer information that let the customer, our customers, make better decisions in those specific places. So one key example is, for instance, optimizing a portfolio, a loan portfolio. So customers can look at their portfolio as a whole and apply analytics that will optimize revenue or can reduce churn if you're looking at, let's say, a mobile company, and then optimize what you want to do with your portfolio, and then analyze what are the possible outcomes of those changes, and they make the right decisions. That's one example of the many capabilities. But like I was saying, as you move to decomposing and wringing out inefficiencies, taking out some of the common things, it makes it even harder for these components to communicate. So what we found, initially we had in this layered architecture, at the top level, you have a packaged business capability. Let's say fraud. Fraud is a whole spectrum of service and capabilities that handle fraud in any part of the life cycle. Well, it's too coarse grain. You break that even further into a series of business components. At the end, you end up with a contact surface with architectural services that provide more technical components of your architecture. So now when you get into this layer, you have things such as event service, the one that I'm responsible for that led to this presentation that I'm doing right now. So these things are not arbitrary. We have worked with our customers and voice of customers, and we find what these business capabilities should be like, and then we work backwards to find out what are the architectural services that need to that fuel those business capabilities. So one of them is our event service. So event service is a horizontal service that is responsible for providing intercommunication of these components, not just the other architectural components, but also the business capabilities. So we began that journey of picking the next generation of event service. We had a ton of architectural principles as part of our North Star architecture, but some of the ones that I put here, these 4 principles, kind of shaped what we wanted and how it colored our selection for the event service. So we're API first, and we weren't before, but API first puts a discipline in front of the engineering departments and architects to come up with these contact surfaces and specifically define these APIs. Separation of concerns, and that will Dapr will come into play in that regard, as well abstraction and isolation and the declarative model. So while we were designing North Star, we were also moving our CI/CD from an imperative approach to a declarative approach, where we have a reduced number of repos, aspirationally 1, but you have a reduced number of repos where you keep the source of truth for anything you deploy in Kubernetes, essentially. That's our target deployment environment. So to achieve these principles, keep them in the backdrop, because you may have similar principles and they're not weird by sense. You may put more or less emphasis on these, but it really made a difference when we actually mapped these principles, at least these big ones, against the software selection. So we began this journey of picking the next generation event message broker. And I broke the definition of an event broker into 4 pieces. Because as you can see in the market, and the gentleman that was before me, he presented, so thank you. But you see these products are, it's a crowded ecosystem with features and differentiators and the different architectures and interaction models and programming paradigms. So how do you compare apples to apples here? So I took a simple approach so I could communicate with a bunch of stakeholders. I said, look, there's a set of core event broker features and adjunct components that make the heart of your event broker. So things such as the cache system, or the cache system, the schema, brokers, and so on. So I could consider those the core part of a broker, storage subsystem, the orchestrator, or the coordinator if you have something like Zookeeper, or now you have Oxa. The next one is the client-facing libraries. And here I got to say that when one of the slippery slopes of selecting this type of event message brokers is that, yes, everybody has a pub sub API or maybe a queuing API or both, but that's your core API. What happens is vendors offer these higher level APIs that are differentiators. So we wanted to be clear in the North architecture, what is our event message broker doing, and it's basically PubSub. And we punted, essentially, we said, all these high-level APIs for data streaming and so on, they haven't coalesced. We're not sure what's coming out. And like it was been mentioned, some of these paradigms are MapReduce type programming paradigms, others are more SQL. So we said that layer belongs to a separate architectural review. So we want to standardize some PubSub and have a good foundation. That was key for us. The third one is interfaces to other capabilities. So this is where you have the peripheral things. If you think of a concentric circle, you have your HADR capabilities. You have your Kubernetes interfaces. So is this thing decorative? Or is it imperative to have good Kubernetes operators to manage every part of the life cycle of an event broker? Yes or no? Are they part of the product, or is this I got to buy them from somebody else? Where is this stuff coming from? Including the billing part, security, observability, and so on. And then finally, we said the other category is all these things that are differentiators. Do they do WASM? Can I implement functions in WASM? Can I do streaming SQL? What are the other advanced features? Whatever it may be that sounds like a differentiator that is not exactly part of the core. This worked for us, because then when I was comparing apples to apples, I had a better idea thought out of where these features fit in. So from the functional and non-functional, there are tons of functional requirements that we had and non-functional. So I wanted to highlight some of the ones that made a difference for us, because you know the conclusion. You know, we picked Stream Native, their private cloud offering. But this is, before we made that choice, we're looking at our requirements. So definitely we want to be clear that we wanted a PubSub API. We're not necessarily interested in those high-level APIs. We run Kafka, and we have Kafka streams, applications, and once you're kind of committed to those APIs, it's difficult to extricate yourself from it. Tenancy and multi-tenancy are crucial. In fact, we looked for a form of subtenancy, which is, a more like a mirror. It's like a fractal approach to tenancy. It's not just having tenants, but subtenants in there built into the architecture. That's aspirational. You can't quite do that even with Pulsar. You can simulate some of it, and definitely you cannot do it with Kafka at all. We needed schema management from our cybersecurity. Essentially, they wanted to enforce schemas more than the application folks. It was cybersecurity enforcing schema management, that you could enforce the rules between producers and consumers, what they could share, and who could modify the schema. So the schema drift and schema evolution was crucial. It was funny, not from the application folks, but from cybersecurity. Different event consumptions. We don't want to have a queuing system in a transactional pub sub system. And we didn't have a requirement for transactions back then. And this is mid to 2023, and both Kafka and Pulsar were still working on coming out with an actual true transaction, ACID type two-phase commit capability inside their brokers. Non-functionals, as you may imagine, for those fraud cases, low latency, high throughput, multi-cloud. And one of the things that were pretty strong, again, from a security standpoint, is we wanted pluggable authentication and pluggable authorization modules with payload encrypted at rest and in motion. So when you look at that, okay, you get an idea of when we did the comparison. One thing that when I began this architectural decision record in the company, one of the requirements was event sourcing. So the idea was to have, as event sourcing predicates, is you don't have just a state database, you have the transitions captured in a log, and if you need state, you just run all these transactions against the log, and then you end up with a state at that point. We move away from that. So for this iteration of the platform, we don't need that, but we wanted an event message broker that could handle that. And with Bookkeeper and tier storage, we have that, and the read API. So it's pretty solid. We may not be using it today, but we wanted to have it. We wanted to have it. So we get to this chart that I presented on the keynote. Again, I'll emphasize that these vendors are all very strong, and they're very competent. I must say that, for instance, I mentioned earlier, Confluent was is our incumbent at the time, and you can see the minuses and the pluses. So for us, it was the flexibility of handy cruise streams and the flexibility of scaling, and we're seeing that today is the complexity of scaling and the cost and the speed for the engineering teams to scale to accommodate customer requirements. Not even new features, but just the current requirements that change. The models change, the AI models change, especially in fraud, that changes. In the case of Red Panda, fascinating achievement at the time to replicate the Kafka APIs, but a completely different engine. It's like a Formula One. So in this case, we love the performance. Red Panda is a Formula One, but then when you present it to the other stakeholders, like cybersecurity and operations, they say, well, we love that Formula One, but we want self-driving capabilities, and we want it to have a sunroof with a nice stair system. That's not a Formula One. That is something else. So some of the examples involve the pluggable. So they wanted pluggable authorization and authentication. At that point, Red Panda was not in that level of maturity. It's a fairly new startup, and they're focused on their core competency. So unfortunately, that didn't work for us. So we're down to Apache Pulsar that has a very good alignment with the features that we want. And we have two vendors. And frankly, it's a toss. And these are really solid vendors. And what did it for us is what I mentioned in the morning, thought leadership with contributions on the Apache Pulsar community. So we love these operators, the fact that save us tons of time and effort in deploying Pulsar clusters very quickly. You just deploy these Helm charts with some of these CRDs, boom, you get a cluster right away. And then within the cluster, you can define tenants, namespaces, and schemas and topics all through your GitOps CI/CD, and it's very, very cool, very well made. And there's room for additional things to be added. The performance benchmark, it was very thorough. They were very impressive, not just the report when we said, look, we need this sort of latency for this profile of transactions. How could you do that? How would you do that? when you've seen the architectures multi-tiers, so you can cut layers, you can put brokers and bookkeeper in the same servers, and you can play games of tuning it. So if you ever work in benchmarking, it is very interesting because you can cut corners and do tricks and so on, cache stuff and so on. Well, they were pretty transparent, saying this is what we do, this is what we can do, and these are the trade-offs, and the report was very comprehensive. And then finally, at the time, they only had pub/sub compatibility in their Kafka on Pulsar. And we said, okay, this is good enough, but we're not interested in emulating Kafka. Now, since then until now, the evolution has been remarkable. So now they have the whole stack of APIs, and we actually ran a functional test against our Kafka systems, and functionally they work like a champ. You can swap them out, boom, and it works. Still a lot of tests that to be thorough. You want to perform stress tests and scaled out tests and do disrupted tests, to see how operationally we can handle it. It's not that it doesn't work; it's how prepare our teams to deal with different operational scenarios when you're going out at scale. Because the North Star architecture is about creativeness, the new things, but it's not being stressed with the level of rigor that you see in our transactional fraud systems, for instance. So that's the story and why we picked String Native. We picked the private Pulsar private cloud offering. We went through the evaluations at FICO, given the type of traffic that we handle. We looked at the managed service was out of the question. We looked at the bring your own cloud approach. We were not terribly, especially cybersecurity, obviously, they were not terribly interested in putting the control plane of the event service under the control of the vendor. So, okay, let's look at the next step is the private cloud, which put the burden on ops teams to run the show themselves. So that's a trade-off, the learning curve. How do you back up? How do you deal with backlog, TTL, all these terms, different types of subscriptions. And I mean, it's a learning curve. It's very powerful. It has a bunch of bells and whistles. How do you scale it? And the training operations teams to run worldwide. I must say this month we deployed in Europe. So we now have in multiple regions around the world, we have String Native for the North Star part and Dapr, which I'm going to get into in a minute. So we picked String Native. Questions about String Native and our picks, because then the other foot fell. Then they said, okay, you guys picked this product, but you know what? We don't want to get tightly coupled with the API, the String Native APIs. It's another API like Kafka. What are you going to do about that? So we went into another journey about decoupling. How do we decouple? We want to be technology stack agnostic. What are we going to do about not being tied to Pulsar itself? What if the new thing comes along, or we go back to Kafka? What would you do? So enter Dapr. So I'll stop here. If you have questions you want to ask about the first part, and then I'll go into. I got to do this fairly fast. Yes, go ahead.
You mentioned about ability to go back and stitch using bookkeeper and all that, right? Sort of a time travel in terms of your data that's in Pulsar. Did you guys build something or
No. But it's there. So the question is, did we build something that uses the backwards API, or it's called a read API. So it's just another client that is part of the Pulsar client stack that doesn't have checkpoints. So it doesn't move forward in the cursor. You just go back and forth, and you can look at what's in your topic back and forth, and it can go into the transparently into your tier storage. So you do a query on a topic, and some of it is in the broker, in the memory, and some of it is sitting on S3, and some in bookkeeper. So that's what I meant. But here what I meant is what I said going back and forth is there was the desire to have an abstraction layer that can quickly allow us to point to Pulsar and then point back to Kafka with minimal change. That's not easy. So enter Dapr. So what Dapr is an open source, it's a CNCF project. It's incubation, and now this year, I don't know exactly in which month, it'll graduate from incubation into the next stage in maturity. So Dapr was originally developed by Microsoft, like the open application model that you saw this morning from Gaurav Saxena. They're about from the same age, 2019 period. So the idea of Dapr, the name is a distributed application runtime. It's a portable, event-driven runtime for building distributed applications across cloud and edge. So what does that mean? It means that Dapr provides a framework with a series of building blocks. And each one of these building blocks provides technology agnostic for certain things. It may be workflow, which is very recent. PubSub, which I encircle in red because that's the module that we're using. But other building blocks include communication between containerized applications running Dapr. They can talk to each other very easily. State management. So a state keeping storage could be Redis, DynamoDB, Azure Cosmos, you name it. It could be PostgreSQL, whatever you want. The key thing about Dapr is that the application API remains the same. And it's through governance. There's no magic here. The people in the community, the Dapr community is very active. They have, each one of these building blocks has application-facing API that's been standardized by negotiation. So anybody that comes in with, say, a new database system has to comply to the application-facing API, and they can add their building block, or you can create a new building block yourselves. This is all written in Go, so it's very lightweight. It's meant to run on Kubernetes, but it also runs on your laptop. And the idea is that it runs with a sidecar. So it leverages the sidecar paradigm in Kubernetes. Now it could be also a daemon set. So where you have a common daemon set running on nodes, and then your container is pointing to those daemon sets. So you're not going to, you save on having to inject sidecars, but you still have a daemon set with memory CPU to handle the requirements, the database asks or the PubSub requests and so on. So this is a general idea of Dapr. You have, if you don't want to use the Dapr API, which has gRPC in the back, you don't use the SDK. You have SDKs for a bunch of languages. But let's say you don't want to use an SDK. You completely want to decouple yourself from Dapr. You use the REST API. Every one of these building blocks has a gRPC API exposed as an SDK and an HTTP REST API. And you pick, one has better performance than the other, but then you decouple yourself. It's a balance. The other thing I can say in the slide, I'll keep it to that. So there's a lot of, you can spend the whole afternoon talking about Dapr. So in general, when we talk about an abstraction layer, this is what was imposed on us. Number one, you should have PubSub that I could access through gRPC and REST. It should be extensible. It should give you some form of end-to-end transaction warranty. So they put on this abstraction layer a higher bar than just exactly one semantics. So, and I'll get into that in a minute. And then finally, that the schemas as contract between publishers and subscribers should use the three schemas that Pulsar supports, and also Kafka as well. So JSON, Avro, and protobufs. You can take a choice on what sort of schema you want to use. On the non-performant is any abstraction layer pays a price in latency. It's a translation layer, so it has to be performant in CPU and memory. It should support OIDC for authentication, and the payloads data should support encryption in motion, like TLS or MTLS. That was the set of requirements. So what we said is, okay, what do we do? Well, we are we still are a Java Spring shop like many of your shops. You develop stuff in Java Spring. So much so that if it's not in Spring, then it doesn't exist. It's sort of like, it's a walled garden of Java-only environments. So that is a bit difficult. You could develop something like this in Java Spring, but then you have the skills, because we have skills in-house to work with Java and Spring, but then some of the pros and cons is, you end up with monoliths. One of the requirements on this layer is that you want to be able to do changes on the abstraction layer and not affect your application side. If you do it on a monolith, on a Java monolith with, say, Spring, if you make a change, you got to recompile, you got to redeploy your containers and so on. It's not easy to build this thing from scratch, an abstraction layer that is performant and has all these capabilities. So we could have built our own FICO sidecar based framework. Look at Dapr, build your own. But that is easier said than done. I mean, it's pretty complex when you study the Dapr specs and what it does. You have decoupling of application broker. You got to be able to do upgrades with minimal change, provided, be able to switch from one middleware to another easily with just a configuration change. Definitely building CRDs, building operators, and so on. It's pretty complicated, and so on. So bottom line is, in Dapr, we found a framework that had all the things that we were looking for, except that it had a bunch of gaps. What were the gaps? The gaps that we had was, number one, out of the box, Dapr supports Pulsar and Kafka and RabbitMQ and a bunch of other guys. These are clients for those particular middlewares. The client in the Dapr sidecar for Pulsar had minimal functionality. For instance, it didn't support schema enforcement in none of these flavors. So it didn't have schema enforcement at all. Second, it didn't support end-to-end encryption. It didn't have OIDC support for authentication. So you want the sidecar to perform OIDC authentication. It only supported the native Pulsar JSON tokens that are providing out of the box in Pulsar. And then it didn't support all the subscriptions types. It had just share, pub sub, the most basic type of subscription. And finally, it didn't support transactions. It wasn't Dapr's fault. It's just that when you look at the Pulsar SDKs, transactions were only supported in Java at the time. It was only in February of this year that they added transaction on the Go SDK. This is a big deal. So as we were proposing the use of Dapr, the adoption was contingent to performance testing and also filling those gaps. What happened was impressive because we were working with the Dapr community as well with a company called Diagrid.io, which is founded by the original creators of Dapr. So it helps us steer these requirements. But what was interesting is that what was impressive is that the changes, all those changes that I mentioned, were done at the sidecar level. And the application-facing API did not have to change at all. So we didn't have to go through a rigorous governance requirements and negotiating with a bunch of people to get these features built into the sidecar, completely transparent to the application API and completely declarative. It's all a configuration file. There was a configuration file. It's just additional parameters to implement those things. So that was, to me, very impressive. All these features were implemented within 6 months, and we still haven't implemented the transactional ones. The transaction, fortunately, in Pulsar, is very transparent to the application API. You just say, I want transactions, and your client doesn't have to know, other than it doesn't have to know. The client is running on the sidecar. So yeah, you have the unit of work boundaries for transactions, but that's hidden in the sidecar. Your application is just doing pub sub. It's the sidecar that has the smarts. When you say, I want transactions turned on, to invoke the right logic to do the beginning of the unit of work, end of any of the work, and then commit, right? So that's the story about how we're done with this part. The next part is performance. So metering is one of the key systems that wants to use Pulsar, and there was a concern, oh, gee, this Dapr, will it perform? Or you're going to suck all the CPU memory. Here's the problem. Here's the preconceived idea is that when you hear sidecar, you hear service mesh, and you hear Istio, and you hear, oh my God, this is going to kill our CPU memory. This is very high CPU. So first of all, Dapr is not a service mesh. It has, at a low end, certain features that may overlap with a service mesh. So you could turn on MTLS in Dapr when Dapr is talking to another application that's using Dapr. And that looks like what a service mesh would do. But other than that, there's no comparison, because in a service mesh, the sidecar, the Istio sidecar, to be specific, is the proxy. It's actually a firewall. So every single packet that goes in and out to that container goes through the firewall, goes to the proxy. That's not the case with Dapr. Dapr works at the layer 7, it's the application level. So if you don't call a database, if you don't do a pub/sub, or if you don't invoke any of the functionality at the application level, you're not using the sidecar at all. So going back to what we did is we did a performance test, and then engineering did their own. So from architecture, we did one, and then now they're repeating, and they're doing another one, more comprehensive with other tools. But we achieve our goal here. We ran our performance test, and the conclusions are as follows. We ran this test with metering. So the idea is the purpose of the benchmark is to see how Dapr would perform when we're capturing metering data out of a containerized application. So think of a containerized application that is receiving transactions from our clients, whatever that may be. It can be a decisioning system that is receiving requests to maybe approve a loan or underwrite a mortgage. Now, these transactions generate metering information that we use to build our customers. So in the background, this container is generating metering transactions. They're being sent to Pulsar. And they're done through the sidecar. The sidecar has the client to Pulsar, so it's publishing on a metering topic. So the first conclusion is the same NIC, the same network interface card that is receiving transactions, is also being used for metering. So if I say, you can't just say that the sidecar is going to add 5% and it's going to consume another half a gig of memory on your container. It's not that simple, because they're sharing the NIC. So you really have to think about that. Just keep it in mind. The second thing is the Dapr sidecar was very easy to tune down using the request parameters in your Kubernetes. And memory was impressive. Just for publishing functions, it only consumes 42 megabytes at most. We beat up our application containers with load, and we exceeded what the application side of the container could do. It's a Java-based application, 1 gig, one full CPU. Dapr could do its job with just 48 megs and 5% of CPU. You can play with caching, so you can boxcar your metering transaction. Maybe instead of 1 per transaction, you say in 5 or 10. That improves performance incredibly, very significantly. I wouldn't say incredibly, but it's very significant. The trade-off is if you lose that pod, you're going to lose 5 records instead of 1 record of metering data, which is valuable. Okay, so that, for us, Dapr with Pulsar performed with fine colors, so we're really happy with it. So where are we going next? So I mentioned in the morning that we are deploying in our North Star, our greenfield. We've deployed Pulsar with Dapr worldwide now, and we're building skills to refactor our current system running Apache Kafka. Now, Kafka, so we have a migration strategy. We would like to lift and shift, so we want to replace Kafka with Stream Native Pulsar and leave the Kafka APIs alone. I mean, that's your stepping stone. But then we're going to start decoupling what is really pops up from the higher level APIs that I mentioned earlier and start understanding this landscape of Rising Wave and Flink and other components you have at the low end. Stream Native's own PF I mean, where does that fit in? Is there a Dapr building block that could help us abstract all these programming paradigms and so on? It's not something that FICO would embark on its own, but it would look out for the community and propose these sort of things. There are efforts in the Dapr community to look at, say, SQL or streaming SQL as a building block, and then use the same principles of technology abstraction, sidecars and daemon sets to abstract that part of the architecture. So that's where we're heading. And I think that's the end of this. And I want to stop here and say if there are questions, because I may be out of time.
Like 2 questions.
Okay, go ahead, guys.
You mentioned about metering system. What is the error rate you observe in your system? How often you see messages getting dropped?
I'm having trouble understanding what you're saying. Let me hear the question. Sorry. Oh, here we go.
You talked about metering system and messages getting dropped, 1 out of 5 something. You mentioned something like that. What is the error rate you observe in which the messages are getting dropped by the Dapr sidecar?
Today, no. I mean, we're not dropping any packets, metering packets. So, and it's not necessarily Dapr. If you forget about Dapr for a minute, and just think of a Go client for Pulsar, like a Java client as well. You only get acknowledgments from Pulsar when Pulsar has persisted that message, not in cache. It's sitting in the hard drive. That's when you get your hard acknowledgement back to your client, whatever it may be. In our case, it's Dapr, but it could be a Java client, whatever it is. It's a Pulsar architecture feature. So the resilience of Pulsar is what makes this durable. And even if you're moving, say, the geo-replicating, so you're moving from one resilient system to another, these handovers are very robust. It's funny you bring that question up because we had conversations with developers who wanted to write their own gRPC code to do this, moving this data from one to the other. One thing is for you to develop your own code and very quickly with just off-the-shelf components. And the other one is writing a Pulsar that has all these hardening features so that you don't lose any record. So it's more about the resiliency features in Pulsar itself than anything else.
Thank you.
Sorry, I joined late. Maybe I might have missed some of the stuff, but I want to ask, like, do you have any, do you guys deal with message duplication? Like, because in Pulsar, I think sometimes you may get duplicate messages, right? So do you have any custom solution for that, or is it okay for your system to get duplicate messages?
So it depends on the user application. We haven't implemented transactions in metering, for instance. The data lake will deal with duplication. We said we don't have to complicate the architecture at the Pulsar level. Because in the data lake, you have all the time in the world, but this is not real-time response to do this sort of thing. You now have transactions in Pulsar. So you really can have a transaction coordinator in Pulsar and you can have transactions essentially where you're making sure there are no duplicates because the context of the transaction is such that you're duplicating a transactional system in Pulsar. Do we want to go that direction? I don't think that's a good idea. I think we need to deal with duplicates at the client level. But that depends on you. I'm of the school that I think that handling of duplicates, specifically the hard no duplicates, that burden shouldn't be put
Yeah, I agree. We do the same thing.
outside.
Yeah.
But the vendors are offering. It's our arms race again. You know, oh, you have transactions as well. Oh, I have transactions as well.
Right.
But then I think it's a performance killer.
Right. Yeah. It kills the performance.